Hello, my name is Todd Peterson. I'm with the Work Zone Management Program at Federal Highway's Office of Operations with the U.S. Department of Transportation, and I'm happy to talk with you today about the federal vision and implementation for the Work Zone Data Exchange. The Work Zone Data Exchange was created in response to the need for a consistent data specification describing work zone activity, one that would be consistent across different producers and users of this information across the project delivery lifecycle. The project delivery lifecycle begins in the planning phase, where work zones are initially envisioned as part of the planning for the multiple stages of construction necessary to complete future projects. Through this planning level of vision of work zones changes during the planning and design phases of a project, it still has value for trip planning, project coordination, and transportation operations planning. When a project goes to construction, that's when the full measure of the WZDX specification can be put to use. When the first cone goes down, a work zone becomes live, and a WZDX record should be published that alerts the public to that active work zone. Multiple WZDX records may be generated for a construction project as the setup of the work zone changes over time to accommodate different phases of construction. When the work is done and the last cone comes up, all the WZDX data records generated during construction become an important historical record of what was happening on the ground at any given time. Having the WZDX data specification is an important step to streamlining operations around work zones. Let's talk about how we can put the WZDX operational framework to work. A big part of the Work Zone Data Initiative was to understand how information on work zone operations is used across different business processes between stakeholders and to map these processes into a coherent framework. This diagram presents a simplified view of this framework that highlights the four key arteries through which work zone data serves operational needs for infrastructure owner-operators and gives an idea of the stakeholders that are associated with each. In the planning realm, WZDX data helps people planning for future events. This can include stakeholders like freight companies planning long-haul freight routing, or even the agencies themselves as they look to minimize the collective impact of multiple work zones that might be involved in construction projects already in the funding pipeline. A future awareness of work zone activity is crucial to proactive transportation planning. Once a project goes live, real-time WZDX data informs a wide array of transportation management needs, which can generally be divided between real-time operations and construction management. Real-time WZDX streamlines traveler information services, interagency coordination, real-time trip routing, and will be a crucial tool in facilitating automated driving systems operating on public roads. It also informs internal agency construction management functions and can assist in construction inspection, asset management, and managing awareness of active work zones where there are workers present and construction taking place versus work zones where there may be long-term traffic control devices retained in the field, but no construction is occurring. This level of awareness is of major significance to agencies and law enforcement agencies in dealing with enforcement of traffic laws associated with work zone safety and has long-term historical value. Speaking of historical value, retainage of WZDX data records supports an agency's ability to participate in post-construction analytics of work zone performance as part of a process of continuous improvement to ensure that agencies keep doing what works well and fix what doesn't. It also supports the critical ability of agencies to maintain an accurate record of work zone traffic records should a legal claim be filed against the agency at some point in the future. Producing a WZDX specification and mapping an operational framework for its use fulfills the federal vision for work zone event data. Looking back, the history of the WZDX goes back to 2017 when Federal Highways initiated the Work Zone Data Initiative. From this effort, a skeleton of the WZDX specification was conceptualized. Active development of version 1.0 of the WZDX specification began in 2018 and convened stakeholders across the industry to help refine that specification into something that would meet everyone's needs. In 2021, Federal Highway awarded grants to 13 agencies to help kickstart broader deployment across the country. Today, in 2022, the success of the grant program has led to Federal Highway's transition of long-term stewardship of the WZDX to a standards development effort supported by the Institute of Transportation Engineers and the Society of Automotive Engineers under the guidance of the American Association of State Highway Transportation Officials under Federal Highway's Connected Work Zones program. This effort aligns with the current pivot within Federal Highway to consider similar applications for operations event data under a new project called Managing Disruptions, which seeks to take the lessons learned from WZDX and apply it to management of other types of non-recurring events that would benefit from a common specification for reporting operational impacts on public roadways. These efforts continue and are part of a 5-year Federal Highway strategic planning effort that will continue through 2026. As of right now, there are 13 agencies currently publishing a WZDX feed, as well as the National Park Service, who operates highways on federal lands throughout the country. Another 11 agencies are currently working towards advancing their organizational capabilities towards producing a WZDX feed. Once complete, this will represent roughly half of American states actively participating in producing WZDX feeds. It's also important to recognize the contribution of private sector industry for their active participation in helping to craft the implementation and broad deployment of WZDX, as these stakeholders are important partners to the infrastructure owner-operators. Broad acknowledgement of the success of the WZDX has been a springboard for adaptation of the WZDX specification for use in different aspects of the work zone information workflow. The WZDX device feed serves an onboard interface of field-installed traffic devices and sensors. The WZDX work zone feed remains the core product, providing full description of work zone activity. The TDX adapts WZDX for fixed restrictions and unplanned incidents, including crashes, natural disasters, or other events that impart a disruption to traffic. The next slides discuss some examples of how the WZDX and related feeds are put to use. The WZDX device feed provides consistent language for collecting information on field-installed devices that can be used to populate data records in a WorkZone data exchange feed. Both types of data have potential applications for use by data consumers. The device feed provides a baseline for hardware vendors and other providers of traffic control solutions to develop products that are interoperable and consistent with the WZDX specification. By making their products compatible with WZDX, they ensure that agencies are purchasing solutions that will not quickly be obsolete as the state of the practice evolves. It also expands the market for developers who can market their products to every agency that has integrated the WZDX into their organizational information workflows. The Wisconsin Department of Transportation serves as one example of how an agency has integrated the WZDX specification into their business processes. Starting from the panel on the right, the Wisconsin Lane Closure System, noted by the circle with WIS LCS, feeds WZDX compliant descriptions of planned work zone activity into their automated traffic management system. As work zones go live, a published WZDX feed is made available to external stakeholders via a statewide API that is available to data aggregators such as Waze, who use this to generate alerts for their subscribers. At the same time, the WZDX specification streamlines internal communications of work zone activity within the agency, making it available for use among other agency programs and partner agencies who need to be responsive to what is going on Wisconsin public roads. Minnesota provides another example of how WZDX streamlines the production of work zone event data using a custom application that can be used by workers to register advanced work zones, active work zones, and maintain the integrity of the WZDX data through the project delivery lifecycle. With a focus on in-vehicle communications, the Michigan DOT has partnered with General Motors and Vermac, a company producing connected traffic control hardware, to deliver real-time information on work zones and worker presence to connected vehicles to improve the quality of information conveyed to the driving public. These early demonstrations of the capability of WZDX to improve management of work zones has informed future plans for standardization of the WZDX specification into a national standard. As mentioned before, Federal Highway will be working with SAE and ITE to advance development of a national standard for WZDX and device feeds for national interoperability. Since most of the involved parties have been involved from day one, we do not expect that the standards development effort will deviate significantly from the progress that has been made to date. For further information on the standards development effort, the email address for the standards development program at ITE is provided here. After 5 years of successful development of the WZDX, Federal Highways is turning its attention to the next steps of the process under the FHWA umbrella of managing disruptions to roadway operations. The managing disruptions data exchanges will extend the WZDX model to a new set of data exchanges focusing on other types of non-recurring events, including incidents, road weather events, and plant special events and other event types, as noted here on this slide. This effort follows a 5-year strategic plan that will build on the idea of convening interested stakeholders from state and local government, private industry, institutions of research, and other parties to establish a portfolio of data exchanges that will complete the need for digitally virtualized operations events. Wrapping up, this slide provides a number of links and resources for learning more about the internal workings of the WZDX specification, including examples of current WZDX feeds, data visualizations based on WZDX data feeds, JSON schema for validating the conformity of candidate WZDX feeds with the full specification, API frameworks for building applications around WZDX feeds, and guidance documents with additional information. Embedded links in this slide will be available to participants through sharing of this slide deck. In closing, I'd like to thank you for your time and interest in the Federal Highway Work Zone Data Exchange effort, and I invite you to reach out to me personally to discuss further. I wish you all the best and look forward to learning from your experiences as well. With kind regards, that brings an end to this presentation.